Hello, today I'm going to introduce iterative and recursive algorithms in C with a couple examples. So first of all, we're going to start with calculating the first digit of a number. So as we know about integer division is if we start with the number 1, 2, 3, 4, by dividing it by 10, we get 1, 2, 3 because the decimal is just dropped. It doesn't matter if this is 9, it should technically round up to 1, 2, 4, but it doesn't matter because with integer division, the last number just gets scrapped. So we can just keep repeatedly dividing until we're left with one digit, because if we divide this by 10, we're left with 1, and that's it. And that's our first digit. So let's do this iteratively first. So what we can do is we can keep looping until n is no longer greater than 9. And what we can do actually is just go n divided by or equals to 10, which is the same as this, by the way. These two lines are the exact same, but I'm going to do it like this, and then I'm going to return n. First, for recursive, it's going to work a little bit differently. So we're first going to, we need a base case for a recursive algorithm. Our base case is basically like, if it matches the condition of the base case, it's going to return some constant value. So if n is less than 10, then we're just going to return n. Otherwise, we're going to return, this is the recursive step, we're going to return the first digit r of n divided by 10. And what this is going to do is it's basically saying, if I pass in first digit recursive of 1, 2, 3, 4, it's like, well, n is 1, 2, 3, 4 is not less than 10. So we're going to return 1,234 divided by 10, which is 1, 2, 3. And then that's still not less than 10. All right, we're gonna return whatever the value of the first digit is divided by 10 again. So it's gonna be 12. That's not less than 10, and then it becomes 1. So then what happens is first digit r at 1 will return 1, which is then given to first digit r of 1, 2, which is given to first digit r 1, 3, and so on. So that's how this works. So now let's test this code out, and we see that we get the right answer for both. Now let's do one for factorial. So factorial I into n. Again, factorial is defined as this. So 5 factorial, for example, is 5 times 4 times 3 times 2 times 1. So n factorial is essentially n multiplied by n minus 1 multiplied by n minus 2 all the way to 1. So what we could do is go like this. Let's go, we'll first set our number to n, and we'll say into I equals n minus 1. I is greater than or equal to 1, or it could just be greater than 0. Actually, we'll go greater than 1 because we don't have to multiply by 1. I minus minus. And we're just going to go fact times equals I. And then we're going to return, not 0, I. Not I, sorry, factorial. So, that's our iterative solution. Now, what about our recursive solution? Well, for recursion, what we could do is say, again, if n equals 1, then return 1. That's our base case, because if it's 1, then I typed r. Oops. Not sure how that happened. But if it's 1, then just return 1. Otherwise, we're going to return factorial r of n minus 1, but we're going to multiply it by n. So basically, we're passing in, if I pass in 5, then it's going to return the factorial of 4 times 5, which will be the factorial of 3 times 4 times 5, which will be factorial of 2 times 3 times 4 times 5, which will be the factorial of 1, which is just 1, times 2 times 3 times 4 times 5. And that's the factorial equation. So we're going to do this again. We'll do 5, and then we'll do factorial I there, factorial r here, and then we'll set these to 5. I use Control D to select and then get the multiple cursors in VS Code, if you're wondering. And if I run, bam, I get my factorials for both. I hope this helps with recursion and iterative algorithms, and thank you for watching. Have a good day.